And here we are to look at our shoreline features of a geologic nature. And so this first one's going to be a spit. And so you can see this very kind of peculiar feature sitting out in here. And so what would have happened is sand gets transported by longshore drift. So it gets drifted along here and then continues to extend out, creating this kind of linear feature that's all made of sand, extending off of the mainland there. And this is going to be what's called a baymouth bar. So you can see there'd be a bay back in here and then the main ocean out in here. And what would have happened is sand would have been transported along here and then started to collect and formed kind of a spit in here. And that spit would have gotten bigger and bigger and bigger until it completely closed off that bay. And so we call that a baymouth bar because it's the mouth of the bay. And then this is one of my favorite features. So these are sea arches, or a sea arch and a sea stack. And so we have to picture is that this land would have extended way out here. So it would have stuck out like this. And then the waves would have come along and eroded parts of this. And there are weaker sections. So this section in here would have been weaker. This section in here would have been weaker. And so what you see is that this whole chunk of rock had gotten removed and eroded away. And so it just left this big hunk that's just left over. So this, if you were to drill down, would be connected all the way back to here. It's just a remnant left over. And this is kind of an incomplete process. So it's just started to erode away at the base here. So it would have started really small and worked its way up to here. And then eventually it's going to keep eroding, and then we're going to have another stack sitting right in here. But in the meantime, we have this really beautiful arch. The next feature is called a tombolo. So here we've got this little island sitting off in here, and here's the mainland. And sometimes what will happen as the waves come in, there's a kind of quiet spot right behind here where sand likes to accumulate. So we've kind of created this little connector bridge from the mainland over to the island, and that's called a tombolo. And it's just in an area of quiet so that the sand can accumulate. And then this is going to be a wave cut platform. And so that's this platform right down in here. And so this is at low tide, so we can actually see it. But when high tide comes up, it'll come up to in here. And the waves are actually just cutting this into rock, cutting this really nice kind of platform or flat surface as it erodes away at that rock material there. And then in this picture, we're actually showing the marine terrace. So this is this really flat, obvious spot up in here. We've got a little piece of it right in here. It's the same elevation as the one in the background. And this would have been an old sea level. Okay, so sea level would have dropped here or land might have risen up. And so this would have been the old surface that you see here now, but it's just this leftover ocean level. And so that's going to be our marine terrace. And you can actually see that in this as well. This would have been an old marine or an old ocean level. So that's a marine terrace back up in here also. All right, and so this is a fjord. And it became very popular with the movie Frozen, so they talk about fjords in there. And it's just a drowned glacial valley. So if you had watched the Erosional glacial features video, you would have seen that these glaciers, as they flowed through these valleys, would leave these good U-shaped valleys. And so once the ice is going to melt, and if sea level rises, those will get drowned out. And so you have this nice fjord in there, and you can see how broad that is, and that's because the ice would have occupied that whole area in there. And this is a barrier island, and so this is a depositional feature. So we've got this set of islands that kind of parallels the coastline here. And so the sand accumulates and creates this kind of first zone of kind of protection, but the sand just accumulates along there and creates these linear islands. And then this is going to be a tidal flat. So this area is really susceptible to the tides. So the tide is going to come in and sea level will rise, and then sea level drops when the tide goes out. And so you have these kind of muddy surfaces that get deposited every day. You're just adding more and more mud and taking a little bit away. And so it's just a super muddy environment. And these are typically very close to where rivers enter the ocean there. And so you just have a lot of fluvial activity as well as this kind of tidal activity. And then this is going to be a lagoon. And so we have that featured over here, kind of where you see my mouse circling on the left-hand side. And so a lagoon is going to be a body of water that's still connected to the main ocean, but protected in some way. So we've got some barrier islands and some coral reefs coming in here that are actually protecting this kind of more quiet body of water. And so we give it a special name because it ends up producing some different deposition just because it is quieter and protected from the open ocean. And then this is going to be an estuary. So it's actually like the fjord, it's a drowned valley, but these valleys would have been carved out by rivers. So the river actually comes in through here and would have extended out into the Pacific Ocean when sea levels were much lower. Same thing, a river would have come in here and joined up and extended out into the ocean. Now sea level has risen, so these lower valley areas have been flooded. And that's called an estuary. And it gets a mix of freshwater and saltwater. The saltwater obviously coming from the ocean, and then the fresh water coming from the rivers that still feed into that system. And then this is a submarine canyon. This is actually off of Monterey Bay, if you're familiar with that, in Northern California. And so this is just a canyon that's actually submarine, so below ocean level. And that would have very likely been cut when sea level was lower. So you have to picture the coast would have been way out here. We would have had these river systems flowing out over what would have been land at the time. Sea level rises, and we still get some carving action. So the erosion doesn't stop there. We still get some failures along the sides and materials that get carried out into the deeper ocean from the shallower parts in these submarine canyons. And so it's one of the ways that we get coarser materials out into deeper parts of the ocean is just shoving them out through these little superhighways. And our last thing we're going to look at are jetties, groins, and breakwaters. So the first one highlighted is going to be these jetties. So it's this linear structure that gets built by man out extending off of the land here. And in this case, we call it a jetty because they're really long, really thin structures in here, and it's actually meant to protect something. And so it's protecting this harbor here. So we're trying to trap the sand so that we don't kind of clog it up in here because we want our boats to be able to go through and get back into that harbor. So we call those linear features jetties. The second one we're featuring are called groins, and they look very similar, right? They're these little linear features that are extending off of the land. They're just smaller, and they're not really meant to protect anything. They're just there to kind of trap that sand and keep our beaches built out. Because you remember our longshore current would be coming along here and would tend to remove all that sand. But this way we can trap it by kind of trapping it up against these vertical walls. And then finally, we have our breakwaters. So these can be built in a couple different orientations, but it's common to see them built kind of parallel to the shoreline. So instead of extending out like this, they're kind of parallel to the shoreline here. And all that it's doing is it's just creating a lower energy environment back here. So it's absorbing some of the wave action, creating a low energy environment where everything kind of just slows down. And it allows that sand to be captured there. And so that those beaches will be built up. And so that would be it for our coastal landforms. Some of them are depositional in nature, some of them are erosional in nature, and then some of these are just man-made to create some depositional features.